Good afternoon, everyone. Thank you so much for spending your day with us. We are at our last breakout session of the day, and it is my pleasure to introduce TAL MALAMED. He has over 15 years of experience in cybersecurity research and engineering. He recently co-founded Cloud Essence, a serverless security company that was acquired by Contrast Security last year. Today, he leads Contrast Security's new innovation center in Israel. Tal, it is my pleasure to introduce you. Take it away.
Thank you. Let me just, all right. Okay, I think you can all see my screen. So thanks everyone for joining. My name is Tal. I'll be talking about serverless security top 10 risks. So let's get started. Just a little bit about who am I, or maybe more accurate, why am I doing this? So you can find me on social media, usually as AppSec. I'm also teaching cybersecurity master's program in Quinnipiac University. It's a remote program, 100% remote. So if you're interested, just shoot me an email. Why serverless? I've been dealing with serverless security in the past couple of years. I was head of security research at Protego Labs, serverless protection company that was acquired by Checkpoint in 2019. Then I started my own company called Cloud Essence, which was acquired by Contrast Security last year. Okay, so let's start. Let's just dive in. In general, serverless is part of cloud native. I'm sure you've heard of it. Cloud native is the future of application development, as IDC predicts by 2021, which is already here. 70% of newly developed enterprises applications will be developed as cloud native applications. That means really a hyper agile architecture using containers, which I'm sure you all do, microservices, and serverless functions. I'm sure you already know that the transformation has already begun. You can hear about it everywhere. All the big companies are now somewhere in this transformation, whether it's Skyscanner, iRobot, that they're leading the pioneering, the cloud native engineering, or if you look a little bit back, you have some other big companies like Xerox, AT&T, MasterCard, etc., Coca-Cola, which are in the middle of the transition, meaning that they now have some kind of a hybrid solution where they have both cloud native applications and monolith. But the growth continues, and we believe that eventually we will all get there. What is cloud native development? It means actually a couple of things. One, the architecture is different. So it's not a monolith application with a big flow, one big flow that starts and ends in a synchronous way. No, instead it's maybe microservices or even nanoservices, many different resources that are connected together in some kind of configuration that eventually brings up the application logic. The cycles are different. They're not monoliths, waterfalls. There are hyper agile, quick iterations, DevOps, or even DevSecOps, if you've heard of it. Processes, less manual processes. Basically, because everything is in the cloud, there is no quick visibility to anything, and we probably need to automate things so we'll be part of the loop of whatever happens in the application. And it goes down to the decision, no more hierarchy decisions, upgrading the server taken by the head of engineering. No, from now on, it's bottom up. Developers push to production on a daily basis, takes the responsibility for security, for development up to production. Serverless architecture, as I mentioned before, can be a little bit complex, but if we do that right, can be great for many reasons. But as you can see here, this is just an example of a somewhat complex, I'd say, architecture of serverless application. You can see many different resources and services connected somehow. So that means that what are the security challenges in that in this kind of architecture is basically that you have to understand that each resource is a standalone resource. Most of them, if we're talking about lambda functions, all those orange parts, they are stateless. So you cannot really maintain the state like in a monolith server. You have one session that controls everything. So you have to take care of security, authentication on every different resource. That can be complex, but as I said, if you're doing it right, you can have security for each one of those resources, and you can really limit the attack surface or the impact. And we'll cover that. So when I say serverless, what does it actually mean? So when we call something serverless, basically we talk about functions. If I talk about AWS, then we call them Lambda functions, Azure functions, Google functions, and others. Many cloud providers or many companies provide some kind of a serverless compute power. Serverless basically means that there are servers, but they are not controlled by the user or by the organization. So whenever you need to execute some code, the cloud provider have a container or a contained environment that spins up just for the purpose of this execution. The code runs, or the architecture is really event-based architecture. So something happens in the cloud, someone uploads a file, someone calls an API, some type of analytical, a database entry was changed, that triggers the code execution. The environment on AWS is, which is really the one that controlling right now the serverless landscape, is a read-only environment. You have one folder, which is /temp, where you can write your own data into. Everything else is read-only and is already there in the environment when the code needs to run. When the code ends or finishes the execution, the runtime environment really concludes and terminates. What it terminates, we will discuss that later. Basically, that means that you cannot control when or on which environment you're running. You just know that when the code executes, you have some kind of environment, which is a read-only, so everything is already built in, and you can run the code. It is not wired to the internet. I don't mean that you cannot connect to the internet. You can call APIs or etc. Or everything that you want, but you cannot access the environment. So there is no SSH, for example, like containers. You cannot SSH to the environment and run anything. The container is just there to run your code. Sorry. The data is temporary, meaning that whatever changes you did to the environment, mainly on the /temp folder, is temporary and is terminated and deleted when the environment or when the execution ends. I put 2 asterisks there because in some cases there could be some leftover from previous executions. So for performance reasons, the cloud provider will reuse environments, but you cannot make any decision based on it because it's random. So you cannot say, hey, if I run this again, the data will remain there. No, you don't know that for sure, so you cannot rely on that. In terms of security, there are 2 interesting parts. We'll talk about them in a few minutes or later in this talk. One is that the code that needs to run is inside the environment. So for your Lambda or your function to run, the environment has the code and it just executes it. The keys also are available inside the environment. So if you want to perform some other actions in the cloud, let's say your function needs to write into the database, DynamoDB or a cloud storage, a blob storage if it's Azure, then in order to have the access to these services or these resources, the keys are already translated and imported to the environment. So when the code runs, it already has the keys to communicate with the other services in the cloud. What about security? So serverless computing is a search term on Google Trends, and you can see that it continues to grow. Of course, there are ups and downs if we take the searches, but you can see there is one way up. On serverless security, for many years, it just remains still. So it seems like no one is really interested in looking into serverless security specific. The one that you can see, and maybe three even here, is just really occasionally, mostly it's between 0 to 1. And I'm sure that this one is me doing this for the last four years. I don't know why people aren't looking for serverless security specifically. I assume that the main thing is that many cases people believe that the security would be the same, or that they don't need to deal with security, and we will discuss that. All right, let's dive into the top 10 risks that in the serverless environment. Then we can deep dive into each one of them and discuss what those risks means, what are the best practices, and then we'll see a demo. The first one is called event injection. Event injection is basically like any other injection attack that you know, but it's called event injection because it's an event-driven architecture. So it doesn't really have to be an input coming directly, synchronously into the function. It can be just an event that happens and call your functions. And we'll see an example in the demo. Broken authentication is another issue. As I showed you before, all resources or most resources are stateless. That means that you have to take care of some kind of authentication, or at least apply a zero trust principle into your environment, because you cannot maintain a state. Of course, you can maintain an out-of-bounds state. This is one way to deal with it. Sensitive data exposure. So in the cloud, we all know there are risks, mostly coming from misconfigurations. We've seen many breaches about open buckets, misconfigured buckets, or storage, open APIs, etc. They can also happen inside your function, your Lambda function. So we already discussed that the keys are inside and the code is inside and the data is inside. So if someone gains access to the environment, they can actually steal those data, and we'll see that. Overprivileged functions. I think this is one of the biggest challenges in cloud functions, basically in serverless functions. As I said, you have to take care of each function separately, so by its own. So you actually have to define permissions for each function. And the problem is that it's not so easy to understand what are the exact permissions that the function needs, because it might need just a single permission, but we don't really know exactly what it is in many cases. So what happens is that developers usually tend to give over permissions to functions just for it to work, and then when security incident happens, then we have to deal with it. Vulnerable dependencies, I won't add so much to that. We all know about third-party libraries which brings vulnerabilities into our code. Insufficient logging and monitoring. The monitoring and the logging exist, but they exist in the cloud. So we don't have a tool that we can inspect the network and see everything. We need to connect to the right services, know how to collect logs, know how to create metrics in order to be able to actually receive the relevant information. Open resources, so Lambdas, they are not really open. You can open APIs, which will lead into your Lambda functions. You can open cloud storage, which can lead to your Lambda. You can open SNS, which can lead to your Lambda, etc. denial of wallet or denial of service. Lambda functions basically have limited amount of executions, parallel executions. So you have in AWS, you have to set a number between 0, so unlimited, to 1000 for your entire set of functions. So if you set it, for example, for 10 to allow other functions to operate in the same in parallel, that means that if someone executes your function 10 times in parallel, then the 11th request will be denied. The problem with that is availability, of course. So if you leave it open and you say, hey, I don't want to have any limitations on my function, let it run as much as possible, then you might encounter a denial of wallet because the payment for the use of functions is pay per use. So in one hand, if you don't use anything, you don't pay. So you can build an entire system with thousands of functions, if not more. And if you don't use them, you won't pay even $1. But if you do use them, then you have to pay. So an attacker could potentially, or an evil actor could potentially just call your API, even if it returns an error because it doesn't have authentication or anything. If it reaches the code, so it means it reaches the Lambda functions, that you pay for this event. So I can just call that a million times or in a loop, and you will pay for that even though nothing happens. And insecure shared space is basically the shared space that is shared between the invocations. So we talked about /temp on a Lambda, and that means that if someone arrives or has access to your runtime in some way, they can access this data. So, for example, if you return data from your /temp environment to the user, and I'm running a next execution, and I land on an environment where there is already data in there, if you're doing something wrong, I don't know, LFI or something like this, I can steal someone else's data. And the last part is insecure secret management. I mentioned the keys are in the environment, but you can add your own keys inside configuration or inside your hard code, on your code, sorry. If that is handled poorly, I can steal those as well. All right, so event injection. There are multiple uncontrolled entry points, so it's not just an HTTP, for example, monolith application with one entry point, one perimeter, entry, asynchronous request with a response. It doesn't work like that anymore, not necessarily at least. You can have multiple uncontrolled entry points, so it's hard to understand where the attack could come from. The traditional injections like command injection, SQL injection, NoSQL injection, etc., they still exist. They just take a different form. You have code injection per language, lambdas, or functions has limits, or they have a list of supported runtimes, Node or JavaScript, Python, Java, C#, etc. So you can have an injection based on your lambdas runtime. There are some kind of a new injection. They're not really new injection, they're just new entry point to your code. So can be an IoT, you can send an email. This email will automatically trigger some code. So you can, through your email, perform injection attack as well as pub sub. The impact of an injection attack depends on the permission that was assigned to this function. So if the function has permission just to write to logs, then even if it's completely open and I can run whatever code I want, it's not that it's not bad. I can steal the code, maybe I can do some other stuff. But the impact inside my cloud is somewhat contained to this service. On the other hand, and we'll see that, if the function has access to other services, mostly if they have open over permission, then I can use the stolen keys from the environment to communicate with other services from my own computer. Best practices, Of course, zero trust. So never trespass or make any assumption regarding input, even if it's not coming from an HTTP request. I showed in Black Hat 2019 how I can perform SQL injection with my voice. I talked to an Alexa device and I managed to steal some information from the database. So if you think about, hey, this is an Alexa device, or this input comes from voice, there is no way someone can hack me. Well, it's not completely true. Other best practices refer to traditional input validation, whitelist, etc. But you have to consider all event types and understand what are the risks in each one. Run functions with least privilege. So whenever your function runs, if you have just the permissions that the function needs, then the attack surface or the blast radius from that impact would be contained. And of course, if you can use commercial tools to protect, detect, test, whatever. Broken authentication, so functions, as I said, stateless. You have multiple entry points, so you have to understand your triggers, how you can authenticate or run access control on them. If you have an API gateway, that's maybe the most common one for APIs, then you can control the authentication on the API itself, on the API gateway. You can use authentication, JOT, API keys, whatever you want. If you have other services like email, how do you control authentication on a function that runs based on an email? That's hard. And you have to understand what you can do to verify not everyone can access these codes. And since there is no one continuous flow, you have to take care of that on multiple ways along the way. So just to make it more visual, if before the traditional application, the monolith application, we had one entry point, one perimeter where we could put the security controls, whether it's the server or the load balancer, but you could always know what's the way in. So if you put your security controls and inputs, validation and everything on there, then you kind of protect it. On a serverless environment, you can have multiple entry points, so someone can just upload a file directly to the cloud storage. This could run a function. If you can process some kind of analytics, that could run a function. API gateway, of course. If the database changes, it can run a function. So the entry point would be different points. So you can use Cognito if you're on AWS. So web services, the cloud providers have they have authentication services. So sometimes you can use that as well. You can also think about storing some kind of a state out of bounds, so maybe on a database or some kind of a quickly reachable service. Sensitive data exposure, of course, whenever we move to the cloud, we always have this concern. So common serverless scenarios that could leak data, and we mentioned that earlier. The data under /temp could be leaked or stolen, sensitive data in the environment variables. Keys are there, but there are also other organization relevant information, maybe other keys to other services, maybe some tokens, maybe permission, some kind of secrets, etc. Sensitive data in open buckets or open storage. Source code is also in the environment, and you can steal it if you have access to it, to the runtime. So whenever possible, delete /temp after the use. Don't assume that it will be deleted automatically, of course, if it's sensitive. Use KMS or other key management services to encrypt environment variables or other secrets that you're using. Secure your cloud storage with the relevant configurations. So make sure they're not public or they are not accessed by anyone. Run as least privilege to reduce, again, the impact. And if you have other tools like on AWS, you have Macy, you can identify sensitive data inside your services. Overprivileged functions. I think close to, I'll say on the hundreds of thousands of functions that I've seen along the way, 90% of them will be misconfigured. Misconfigured doesn't mean critically misconfigured. It can be just misconfigured with maybe more access than it needs. The severity could differ between, oh, I have read access to the logs system, even though I don't need it. That's one. Or I could have permissions to run any command on IAM service, identity and access management service. So in that case, I could change the entire set of permissions in the account, including changing access to resources, accessing other services, etc. In an extreme case, I could really take over the entire cloud. So again, if I have access to the IAM service and I can access and modify users or create users or change service permissions, then I can really eventually do whatever I want. Let's see an example. So this is a Python-based Lambda function code. It doesn't do anything interesting here, but you can see DynamoDB is the database service, AWS database service that it's using some kind of a table that is taken from the environment variable. And the action that it performs is put item, which is just writing one entry to the table. When the developer needs to create the permissions for this function, he will go to Stack Overflow, he will go to AWS documentation, or he will go to Bodo 3, which is the service right now, and try to inspect. In many cases, what he will come up with is, hey, I'm still in development, so let me just put whatever permission I can to make sure it will work, also to cover future changes. So I'll put the action on the DynamoDB wildcard. The wildcard here is basically means that the function can perform any action, any activity in the service. That means reading data, writing data, creating tables, deleting tables, even other tables. Like if the table here is marked with a wildcard, that means that this specific function could, if someone has access to the runtime, if someone changes the code, could do whatever it wants or whatever the user wants on any table in the cloud, even if it's unrelated to the system or to the application. What should have been done is that the developer should have understood or know how to transform actions in the code to actions and permissions. In this case, it's quite easily translated, and then set the resource to the specific resource that is required to be accessed. This will limit that even someone can run, let's say you have free access to the code and you can run whatever code you want, you are still limited to one entry point at a time on this specific table. Otherwise, the cloud itself, the infrastructure will prevent any other activity from it. So review each resource, its function, and apply list privilege when you can. When it's a one function, two, three, it's easy. When you have millions, and I know customers with millions of functions, you have to automate. There is no other way around that. Vulnerable dependencies. Okay, we know it's not new. Functions may have 100 lines of code, it's very common, but they bring everything with them. So they have a lot of dependencies. Just make sure you scan them or you make sure you use only what you need. Insufficient logging and monitoring. It's more difficult. The reason that it's more difficult is that because the tools that are already being available for us are not available anymore. Of course, there are new tools right now, so you can just use any other commercial tools. But if you want to use it by yourself or create your own logging and monitoring, you have to connect to the right services in the cloud and collect the relevant metrics. It's not so easy. Once you do, if you add some functionality around it, maybe reporting, sending the information to relevant locations. So if there is an error, send a Slack notification or something like this. It could work, but it's a lot of work. So we don't own the infrastructure, so there are no tools to deploy easily. There are some ways to do that. There are some commercial tools that does that. All right, it's time for the demo. So what happens? We have the attacker, we have a cloud storage, so a bucket, here, and we have a Lambda function. What happens is when the attacker uploads a file to the storage directly, it doesn't go through a server, then this bucket will trigger this function. So the attacker sends a malicious file, in this case, to the bucket. The bucket triggers the Lambda function. Because the Lambda function is vulnerable, the Lambda function code is vulnerable, and the file is malicious, it will tell the function to send the keys to the user, maybe out of bound because it's not talking to it directly. And then the attacker will use these keys to interact with other services. We'll see the example. So let me run this video. So what we have here is DVSA, a damn vulnerable serverless application, an application that I created. It's open source. It has dozens of services, so I'm just logging in here. It's vulnerable by design. One of the pages that exists here is the feedback form. So I can send any feedback here to the creators of the owners of the site. In this case, it's me, and I can also attach a file. So I can choose any file I want. Of course, in this case, there are no restrictions, so I'll just upload one file. And I'm inspecting the request and the response to see what's going on. And basically, I send a file name. The function uses the same file name and gives me a URL, a signed URL, to upload directly to a cloud service. So I'm not talking to a server. I'm uploading the file directly to the cloud storage. In this case, it's a bucket. And then the bucket triggers the Lambda function. So here, of course, the Lambda is vulnerable to a simple attack, command injection. So what I can add here is putting a curl request with the environment variable, and will print the environment variable to this URL, hacker.ngrok.url. This is an HTTP tunnel that I have on my own computer, so on my workstation. So now I will upload this file, and once it's been accepted, I can do a send feedback. It will upload it to the bucket. And then on the right side here, you can see that I got some requests. These requests came from the function, even though I wasn't talking to it directly. Those base64, this is the base64 environment variable. We'll just decode it. And you can see that I have the environment variables here. The environment variables contain some sensitive data. So what I'm doing here is I'm posting it and creating a profile on my computer. And then I keep the relevant parts, which are secret, the access key, and the session key. Once I did, I can use this profile that I created with these keys to communicate with the cloud from my own workstation as if I am the function itself. So now I'm using AWS CLI commands. S3 ls will just print all the buckets in the cloud, in the account. All the buckets in the cloud, not just those of the application, but everything else as well, because the function has permissions to do so. Now I will inspect one specific bucket, and you can see that I found some folders. Moving forward, I can see that there are files. So now I will do a get object operation, still with my profile, and I will steal this specific file. I will download it. Get object will download it. I'm downloading it to /temp. All right, let's read the file, see what's inside. You can see there is a receipt there, and then not only I can read the file, but I can also modify the file and upload it. When I upload it again, I can either override the original one, or I can create a new one like I will do now. Basically, I could even delete the bucket. All right, so I uploaded it, and now you can see that the file exists in the cloud. All right, let's go back to the presentation. We're almost there. Okay, so the OWASP Serverless Top 10 is an open source project, part of OWASP. right now, the state of it is it takes the original OWASP top 10, the last one, not the new one, and interprets it to serverless. How would each risk from the top 10 would look like in a serverless environment, where we want to create a serverless tailored top 10 report, and we're still running on open call. So if you have some information, if your organization has some information, we'll be happy to hear. All right, what about scaling security or scale your security among serverless development? So there are a lot of services and not the resources that we use. There are a lot of services in general, and we don't know the security on, we cannot, or it's hard to be an expert in security of each and one of them. The developments are frequent, so it's hard for AppSec teams to scale as development. It's hard to understand what resource talks to another because it's just a configuration made by the developer. There are many developers and few security teams, so people. So it's hard, even harder when the deployments are frequent. It's hard to understand what's important. There is no always API, it's a web, a front-end application that you can test, not only. So sometimes it's really hard to understand. And it's a common mistake thinking that the security is exactly the same. It is basically AppSec, but it's not exactly the same. And another question is, who takes care of security misconfiguration in the cloud? This is basically comes in different forms. The organization, you have DevOps taking care of that. Engineers sometimes own that in their own code, and security teams will always be involved. So there is some kind of a relationship that you need to understand. What about testing serverless application with traditional tools? So the cloud is not just a perimeter and a code. The cloud is different. It's many functions, many resources, and many services connected together with configuration, different flows and different relationships. And when you run security tools like a DAST or a SAST or an IAST that you have right now, they aren't really able to understand that. They are ignorant to the environments on the context. So whatever is cloud related, it's not part of their work, and it's a mistake. So you'll get bad results or false positives or false negative. They're really blind to knowledge, services, and resources. You cannot run a DAST tool over a function that runs with your Alexa device. So there is no URL for it. And based on that, it blocks the developers, it's disruptive to the CI/CD, and it's hard to scale. So it's basically not a good choice right now. What we do is something a little bit different. We sit in the cloud and we inspect everything that goes there automatically, so you don't even have to tell the security team, hey, please test this API I just deployed. We already know that, and we scan each service and each resource, trying to find which one is vulnerable. Because we live inside the cloud, we can get this information, and we can even understand the actual impact. If you want to practice on serverless security, there is another open source project. I mentioned that before under GitHub. It's called DVSA, Damn Vulnerable Serverless Application. Is a vulnerable by design application which you can just deploy with 3 clicks, really. You don't need to know anything to how to deploy. Just have to have an AWS account and deploy it. But beware, if you do not deploy it on any account with sensitive information, definitely not in production, because the resources there are misconfigured and can cause some chaos. You can go to this URL and see there are some examples and some documentation. That's it. Thank you very much, everyone who attended. If you're interested in learning more or just talking about serverless or AppSec or anything else, just shoot me an email, tal.melamed@contrastsecurity.com. Thanks.
Thank you, Tal. It looks like we do have a couple questions here if you want to address those. So AWS says Lambda encrypts data in transit at rest, but I assume it's not encrypted at the time of processing. Is this one of the main vulnerabilities?
It's like any other when you say encrypted in transit, so you use HTTP and encrypted in REST, AWS use default keys for the service. But yeah, when you are in runtime, then everything is already decoded. So everything is in the environment. So the keys, the code, the data is already decoded is not the right word, but it's in plain text. So yeah, this is one of the problems. But it was before the cloud, and it also in the cloud. You just have to do two things. One is make sure you encrypt sensitive data with services like KMS or any other keys, and just open it when you need it with your own keys or access to specific keys. And of course, make sure no one has access to your runtime. No one that doesn't needs to be there.